Hey, this is going to be an experiment in using Flappy Bird. So I haven't tried running Flappy Bird at all. I'm currently in the middle of running some trainings on my instances for some Doom games. I've got one running My Way Home using policy gradients and one running some other scenario. And so while those train, I figured let's try Flappy Bird. I googled around and I found this repository that lets you play Flappy Bird. It's not designed for reinforcement learning. It's just like lets you. I don't know. It's Flappy Bird implemented in Python, something like that. So yeah. So let's clone this and have a look. So let's try running it first. So I'm gonna. I don't know. Python Flappy seems. Probably need to set it up. Okay. Nothing's. All right, so basically I've got a spacebar control, and you can see I'm really great at Flappy Bird. I mean, I'm not, that's why I want to get the computer to play for me, because I'm kind of, oh wow, doing okay actually. All right, there we go, I got up to 4. All right, so it obviously runs. Okay. So then what have we got here? We've got flappy.py, setup.py, pip file. These are all files except for assets. And assets is just going to be. So we just got like some audio and some sprites. So basically everything should be in flappy.py. So maybe it's like super simple. I don't know. Let's have a look what's in flappy.py. By the way, I checked the license and it's got an MIT license, so that should be fine. There we go, MIT license. They nearly filled in the year, the copyright. Okay, so Flappy. All right, let's go down to the bottom. So it's calling main, and main is I should probably do search or something like that, but I'm really lazy and I'm just scrolling. I might, if I keep scrolling more, I'll probably actually like search for it. You know what? Let's just do search. All right, so we found our main. So it's initialized, so it's using Pygame. I mean, I've used Pygame before. It's cool. Don't know what this does. Let's just check this. Like, what caption is that? Oh, right, that's that one. All right, we can keep that one. That seems fine. Screen width and screen width. This must be some things I think. We should probably make this smaller. Can we? 285, 512. But what happens if we make this smaller? Like, is that going to break the game? Like, if I make this like say 256 and this is like 144, is that going to like mean everything is way too big? I don't know. I think that kind of breaks the game. All right, so basically we're going to keep the existing resolution and we'll have to reduce the resolution for ourselves somehow. I mean, I guess we could hack around with things like this, but we won't. All right, so MAME. So we've got clock in it, blah blah blah. We are not using wind sounds while true. Uh, Wait, what? All right, show welcome animation. I don't think. What happens if we get rid of that? Huh? Oh, I see. Okay, so this is just an object, it doesn't do anything. So then we go to main game and then show gamer. Can we get rid of that? All right, that's pretty good. And then main game. Okay, um, so Where do we start the game? This is all initializing stuff. So, I mean, I reckon if we go print at the start, we haven't actually started the game at this point. Oh, we don't get at the start. Oh, we don't get. Oh, right. Okay. So at this point, we've actually already started the game. So what about here? Like, have we started the game at that point? Like, have we clicked something? Oh, so we don't get to here. All right. So we don't get to here until we started the game. All right. So let's go back into def main. Um, so after show welcome animation. So all right, so this is not just an object, this is actually doing something. And I don't know where we want the movement info. I don't know what that is. So let's have a look at this show outcome animation. And all right, so it's just gonna wait until we start, and I guess we can change that to world false, right? And so then it's just gonna immediately start. Non-type object. All right, fine. Um, so this is gonna return something. It's gonna return a movement info. Where is it returning something? While true, for event. So this is where it's starting the game. Oh, here's the movement info, right? So we could just put this here, I guess. Maybe. All right, so whoops, wow. What the hell? What was that? What was that bit at the start? What's happening now? Why are there no pipes? All right, okay. So there must be something happening before that. So while true, um, maybe we should run this, let this loop run once. Um, done first loop it equal false, and then done sort of true, and then we're just going to return this. Oh, you know what? Oh yeah, right. Let's put this at the end of this loop, and then if done first it or the other stuff. All right, so basically it's going to go through this loop once, doing whatever this stuff does, and then it's going to start. No, it's not. It's going to do. What did I do wrong? Done first it is true. Oh, right, because we've got this for event. Yeah, all right. So, all right, so we're going to lift this out, and we're going to do. You know what? We can just stick this at the end here, right? And then we don't need all this done first yet, but anyway. So this should like do, there we go. So it just starts immediately. Okay, cool. All right, so now we don't need to like press anything to start. We just, although I mean, it's not terrible to get the computer to have to press something to start, but oh, there's some screen right at the start. Did you see that? Kind of want to get rid of that. Can we get rid of that? Message. What about what's this stuff? Do we want this message? That's cleaner, right? Right, it just does this nothing when I start. It just goes straight to here. All right, so this is kind of what we want. And then we want a way to control this from Python, like from our program. So how are we going to do that? How are we going to do that? So basically what I'm imagining is, so we want some loop in our program like, well, like the same as BizD, right? for episode in count, and then while game dot not finished or whatever. State equal blah 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 blah, action equal blah 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 blah, game dot action, and then that's going to give a reward. So in this case, our reward, the game won't give us a reward until the end, and basically the reward will be like, how long did we last? Oh, we do get, there is a reward. We got the points, right? Like when we play it, like you see these points that appear, like this 0, 1, 2, etc. All right, I'm gonna stop this video just in case it didn't record, because like so many times I have like an hour-long video and it didn't. All right, so that was recording, so that's great. Okay, so yeah, so there is some sort of notion of points that we can get during the game. Anyway, so how are we going to do this? So we've got this main thing, and here there is a loop, and we kind of want to get into this loop somehow. Oh wait, no, main game, right? This loop, right? So let's add our own script here. Subler, where are we? R script. I'm just going to call it R script for now. And this can do import Flappy. And all right, run. And then right, and then the run is just going to call flappy.main for now. Yeah, that should work, right? So I just need to do like Python path equal dot Python path script. Yeah, so that works unchanged. Right, and then we're going to kind of gradually migrate stuff somehow. Okay, so this main calls, well, we're calling main, which is this. So let's have, then the next thing is going to be this. So let's make that return the movement info and not call this. And then we'll call that in ours. So this main is now going to return a movement info. And we've got this script here. And then this is kind of called flappy.main game. So this should still work. Because we just, what went wrong? Some of this is, so indent using spaces. All right. Yeah, okay, that continues to work. Right, so now we've got access to main game. We're calling main game directly. And then we need to do something with main game. So we've got this while loop here, right? So let's split this out. So we'll have a method called step, and then this is going to have a whole bunch of stuff in it. So we'll get rid of the while true, and we're going to have to pass a whole bunch of stuff to this somehow. But we'll figure that out. Like, hopefully we'll just get an error if we forget stuff. Right, so main game. So right now we're going to call main game followed by step. So we call main game once, and then we do flappy dot step. Like, it's going to be something like while true, flappy dot step. So that's not going to work. It's going to crash because, oh, what? Seriously? It worked? Wait, what happened? Line 8. Oh, no, something. Oh, I forgot to save it. No wonder it ran. Right, so it should crash basically because it's missing too much stuff, right? It's missing player X. So now we're going to have to move a whole bunch of this stuff around. So We should probably switch to Visual Studio Code. I think I think moving to Visual Studio Code will be good. I'm not sure. Let's see. I'm gonna restart the video in case it's not recording or something. All right, so it was actually recording, which is good. Twice in a row. All right, so let's open a folder, and the folder we're going to open is going to be Flappy Bird here. I know. Well, I don't know. We'll see what happens. Right, so we've got our script, and we've got flappy.py, and let's change this to like Vizdoom, because that's where we installed everything, probably. All right, now if we go down to main game, no, if we go down to step, right, so now we see all of the stuff that's not defined, which is great. All right, so I mean, so it's all of this stuff, right? So we could make this into a class, I guess, called Flappy, and we'll put the step into that class too, and then we can just add everything into self, right? So where did that go? And then we can make this into an init, and then it's going to be self, and then I don't know what this loop editor is from. Oh, I see. It's just assigning all to 0. Right, and then we're just going to like assign all these things to self that are in like that is being signaled as not being used. Right, and then we can just use those in the other method and everything should be fine. I mean, a lot of stuff will be fine. And then we should be a lot of the way there. At this point, now we've broken out the step into a separate thing, and then we just need to deal with the action and detecting the end of the game and the reward, none of which sound terribly hard. We'll see. So, I mean, the action, there should be like something that's doing Pygame detect events or something somewhere, right? I mean, there will be. All right, so here we're going to do like flappy equal flappy dot, what did we call it? Flappy. Flappy. So flappy dot flappy, and we're passing in movement info. And then here we're going to do flappy dot start. So this should run, hopefully. Like, I mean, it might have a few things undefined. 5, what? Oh, right. So as flat or something. What? I thought I'd saved it. Line 5. Line 5. Oh, flop. Okay, so line 249. We're going to have a few things that are not defined because, like, because I missed them or some other reasons. Oh, if crash test, this is when we lose. Oh, cool. All right, so if we get this, oh, we've got our score. Oh, well, that's fantastic. That solves pretty much everything. This player flapped, isn't player flapped? All of these things that are kind of like dark blue, we need to change. This is why we're using Visual Studio, because it makes this quite a lot easier. All right, let's have to go with that. Okay, cool. It's not detecting my keystrokes. Oh wait, 259. It should be still detecting my keystrokes, so there's probably something I haven't assigned yet. So here we've got the for event in pygame event.get. This should still be, this should still work. Yeah, key space. Maybe there's something here I'm doing wrongly. I don't know, let's see. Like we're not, oh okay, it's working now. Okay, cool, so it works. So let's try to get faster. Oh, that didn't work. What happened there? So at that point, we should detect the crash. So res equal if res, and then we're going to detect if it crashed, right? So when it crashed, we get this thing. What else do we have? If we go all to the end, then what's the return? Nothing. So if it returns none, oh, I see. I clicked that thing. So basically, if it returns none, then right. So well, let's have a look. Print res, and when we crash, it's going to be not none, and the rest of the time it's going to be none. That's my prediction. I mean, I don't know if that's true. Right, so this none. As soon as I crash, it's not none. Okay, cool. All right. So, uh, end game. Well, I guess we can call it res. And then end game equal res is not none. All right. While not end game. End game equal false. All right. So this is looping over the steps, and then for episode in, I discovered this thing called itchtools.count. I mean, I kind of discovered it a while ago, but I didn't know how to use it. But I mean, I always forgot it. So anyway, so now I've figured it out. Right, so let's do print episode. Here we can have like step num is 0. You know what? We can actually have for step num in itchtools.count. This is like the second time in my life I use this. And then basically, if end game, then break. And then here we can have, well, that we just do that. All right, so episode 0, and then episode 1. Okay, 268. Oh, you know the other thing we have to do is we actually have to get like the screen, the contents of the screen. I think what happened then is I went through a pipe, so it got a point and there's a sound. Wow, I think this is the best I've ever done. There we go. All right, so episode 1, episode 2, episode 3. Okay, so we can close episodes and detect things. So then the next things we need to do is one, find out what's on the screen, like so that we can feed that to our models. We need to have that as like at least as a NumPy array for now, maybe as a torch tensor, and also we need to be able to feed in the action. So feeding the action should be easy. I guess we can just do that first. So basically in the step, we're going to have the action, and it's just a Boolean because either we're pressing the space or not. We're not going to have any of this. Oh, I guess, oh, you know what? We can take this out. If action, then we do this. And we'll get rid of all of this. But this is like the event handling from Pygame, and we're just going to do it ourselves. So if action, and then we should test that. So basically, right, so I'm not going to be able to control it anymore. And so this is going to be action. And then this is going to be action equal like random dot rand in. How does that work? Import random dot rand int. Is it like 0,1? Yeah. Okay. So this is going to be random dot rand int 0,1. Right. So it's going to. We should probably make it less likely actually. Like, can we do random dot rand? That's probably we want it to be linear, not normal distribution. Random dot random. Okay, so that looks okay, so that's cool. So we can use that as like a probability. So if so action equal, so basically we're going to pick a random number between 0 and 1. If that number is greater than 0.9, we're going to have flat. Okay, so we're going to do random dot random is greater than 0.9. All right, so if this is greater than 0.9, action will be true, otherwise it will be false. Hopefully. So I won't be able to control this anymore, so it's going to crash for sure. I mean, the bird is going to crash into stuff, but that's fine. Okay, so it's jumping. Cool. All right, so okay, so this is going pretty well. All right, so we can run the game. We can find out when it's finished. We should get the reward, right? So the reward is reward equal res. So the reward comes from here. It comes from score, res.score. So episode reward. Here we go. You know what? I'm gonna play it. Oh, I can't play it anymore. Well, this is gonna be 0 each time, but fine. All right, so we get result 0. If it happens to go through a pipe randomly, we'll get. It nearly went through a pipe. Didn't land. Yeah, it's never going to get through. I mean, if we played it enough times, it would randomly get through. It seems like the 90%, the 10% ratio is not bad. Oh, there we go. Oh, reward one. Yeah. Okay, great. So that worked. All right, so we can control it from Python using this action. We can get the reward. We can run the game. So what's left to do is what is being displayed on the game. All right, so the next thing we want to do is find out what's displayed on the screen. You know what? A big rule in these things is you should always do the high risk fix first, and this is the high risk thing, and we're doing it last. Anyway, so screen.blit seems like, yeah, well, let's Google. Like, hopefully it's not using OpenGL or something, because it's really hard to get screen contents. How to capture a Pygame screen. No, that's not good. Really? Seriously? That will be so slow. That will be really slow. It's even. That will be super slow. That's not good. Window. What's window? pg.display.set mode size. Is it this window thing? Yeah, this should be better. Like, I think this is what we want. So it looks like you can just do like window.copy or window or something like that. This looks interesting. What's this? So step. What are all these uppercase things? Global screen. That must come from pygame.locals, I guess. Pygame.display. Oh, screen equal. Oh, screen is what we want. We want the screen. Where is screen from? Is it from pygame.locals? So let's just return it. We're going to return screen from here. So here in our script, we're going to get screen from here. Aha. And then, well, what's that? So x3 equal print x3, import pygame. I don't know. Surfaces must not be locked during blit. Interesting. Well, it looks like we got our image. So we're very, very close. Um, so where is the step? The main, the class, the step. So locked during blit. Screen.bit, screen.blit, screen.blit, display.update. What if we returned it from here? Well, what if we just like printed this thing? So this is uppercase screen. Actually, it's not defined. What? Oh yay, we've got the state. Right, so we're going to return the state from here. Um, so this is so we're going to return a non-state here and true meaning the game finished and then the result. And here we're going to return the state false, the game is not finished, and none. All right, so then here we're going to get uh, like, I don't know, screen buffer or something. Screen buff, finished, and res. Oh, we can call this end game. All right, and then this screen buff, if we import torch, we can make screen buff t equal torch dot tensor screen buff, and then print the size of this. I believe it is longs. We can print the D type. Okay, that broke. Um, what? Is that because it's returning null or something? Screen buff. So we've got a list of three, list of three, list of three. Like, I feel like the error means that there must be a stride. Oh, no. I don't understand that. Wait, oh, it's a NumPy array. Oh, really? So we can just do screen buff t equal torch dot from NumPy screen buff. I mean, we can't. It gives an error of that. So print screen buff dot shape. Yeah, so this is the dimensions of the screen, then this is the number of colors. So where would it say one stride is negative? So it says we should do copy. So let's do copy. Services must be locked during play. Let's Google that. You're using a pixel array, but using a pixel array locks your surface. Does you explicitly have to delete it once it's not used anymore, and the surface should perform operations in the same scope. Del pixel array. Okay. So maybe. Cool. Okay. That's great. It's working. What was that? Line 20. Yeah, I mean, we're returning none at the end. So the only thing is, right at the start, we won't have a screen for the very first action. We could do this. And then we will have a screen at the first action. So then we'll go here. Right, so now we have a screen buff. Oh, we're still gonna need to do this later on. We still need to do this. We'll get rid of this copy, we don't need it. I think. Right, so we should have a screen buff at the start of each step, which we're going to use to generate our action. Then we get a screen buff that will feed into the next step. And then on the last step, then we just break because we finished the game. I think that's it. So then all we have to do is feed that into our convolutional network and pay lots of dollars to train it. Uh, 16 action. So here we're not going to do anything. We'll just gradually fall down. That's fine. All right, there we go. Let's get rid of this spam. Cool. Oh, wait, what's that? 22. Yeah. Just put that down here. All right. Cool. I think that's that done. If you liked it, if you got this far, please click like, and I'll see you when we start training. See you.